Hello. Yes, I'm audible to all. Hello.
Yes, sir. Audible.
Okay. So, how many of you have joined till now? Only 21. Yes. Hello.
Yes, sir.
Hmm. So, how many of you actually
Actually,
were?
this
Yes.
uh, initially this many only join. Then afterward, people join also.
So they will join.
Yes, sir. We can
So,
start.
shall I start?
Yes, sir. Please, please.
Okay.
Okay. Is the slide is visible?
No, sir. Not. Yeah, yeah.
Yes, sir.
Is it visible now?
Yes, sir.
Yes.
Please tell me. Is it visible?
It's visible, sir. Visible.
Okay. 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 Good afternoon to all. So let me introduce myself, Ganeshwar Nath, as professor from Department of Physics from BCSUT Burla. So this is actually assigned course to me for this MPH-005 electronics. So in this structure or in this course actually that you have the first electron devices and the electron circuits, operational amplifiers, and some are power supply, which include special electron circuits, microprocessor and microcontrollers, all the things. I think that you all of you got the part this syllabus uh, from the part IGNO. Okay. Yes. Am I audible to all?
Yes, 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 sir.
Okay. Okay. So let me start with actually some fundamental ideas about this electron devices. And in this actually, particularly we have discussed actually some diodes, the concept of diodes and their construction working, biasing, and also the part IV characteristics and the frequency response of all these different type of diodes. Okay, and some of the applications. So in this contest, let me start with the part basic fundamentals of this part, this PN junction diode. I put in the part some of the part some points like the part you all of you know as you are already part in the physics background. You may have read the part actually. These diodes are part simple semiconductor devices which have the port two basically the two layers and the two terminals and a single junction. So which is the part basic characteristics of a part PN junction diode. And the junction is part normal diodes can be formed through semiconductors like p-type and part n-type. You all of you know the part the p-type is a positive crystal and n is the part negative crystal, and it may be part made up of germanium and part silicon. And the terminal p-type is basically known as part actually anode, and this n-type is basically known as part cathodes. And you know this so now in the market actually the different type of diodes are available. So depending upon the different requirements and also the their efficiency and also the function, we have the different classification of the diodes. Like particularly we will discuss in this model, that is actually power diode, and also this LED, laser, solar cell, photodiode, varicap, and the part pin diode, and tunnel diode, and part gone diodes. So I have just put the part some of the part ideas, just like first power diode. So all of you know, in this so this power diode is actually different from that of the part general diode. So in the context of its fabrication, its working. So if you can find actually this basic structure, I maybe put it part. You can is the my slide is part moving?
No, sir.
Okay, 1 minute. Is now visible?
Yes, sir.
Yes, please.
Slide is not moving. Yes. Is it someone is controlling my PPT there? But why the slides are not moving?
Is your computer gets hang?
Just wait 1 minute, Akhil. What problem? Just let me see.
Okay, sir.
খুচরো নেই আমার কাছে, ওইটাই পড়েছিল।
Is the slide is moving?
Yes, sir.
But I think I'm in the first slide where slide is not moving. Someone is controlling. Just 1 minute. Okay, what's problem? Actually, slide is not moving. 1 minute, 1 minute. Let me see.
Now it was moving, sir. Now we can see, sir, second slide. Now we can see.
Am I audible to all?
Yes, sir.
So you please tell me that whether the slide is part actually visible or not. Tell me.
Sir, slide is not visible now, but slide was moving. It is moving right now.
It's not moving.
It is
Okay.
visible now.
Is it moving now?
Yes, sir. Now
Okay.
it is moving, sir.
Okay. Sorry, actually for this actually some technical problem. So is it now? So we need the full screen or this is visible to you?
It's okay, sir.
Is it okay now? Okay, fine. Thank you. Uh, Sorry for that actually for some technical issue actually. So all of you know this is for power diet. So this power diode actually is just like a part general diode, but the problem is there, or this is actually somewhat different in part construction. I have written here. This power diode is a diode having the two terminal like the anode and cathode, and it has just like the p and part n junctions. And these diodes are part basically known as power diode, because it's only different from its general diode. It's due to its part complex construction, and also the part from the operational point of view, because these are called actually power diode. As all of you know, so nowadays actually we need the part low power devices has to so which has the part greater efficiency, because always we are requiring for the part small power, less amount of power but high efficiency. So on the basis of that, actually we are just making a part some or just diodes are part made up of, that is called the power diodes. And these diodes are part basically known so basically used in part high electronic circuits. So I'll come to the part in the due course. So you can see these are the parts, some of the components available in the part market. These are called actually some devices, or these are called the power diode. Some input that I put it here, okay, or some figures. So in power electronic circuit, this diode actually plays good essential role, and it can be used as a rectifier, so in the converter circuit, and also the voltage regulation circuit, and the reverse voltage protection, etc. And these diodes are related to signal diodes, except for a slight disparity in part its construction, because I've already told you this power diode is somewhat different from that of the general diode, because if you can see, these diodes are actually, you can see here, so these are now the different type of diode depending upon the part its work and part efficiency and also the part function. And these diodes are part related to signal diode, except for slight disparity in its part construction. And here you can find, when you can come to its construction, the doping level in signal diode for both p and the part n layer is same. Doping means all of you know some addition of the part impurity to that of the pure semiconductor, okay. And depending upon the part doping concentrations, that may be p plus and n plus, means that is called heavily doped, and also the part lightly doped, okay. And this doping level in signal diodes, or means power diode, for both p layer and n layer is same. Whereas in power diodes, the junction can be formed among a heavily doped p plus layer and lightly doped n layer. So that means when I can construct the part this power diode, I must has to be put the part some of the part diodes, some of the regions are heavily doped and some are the part lightly doped. So if you can go to the part construction, actually you can see this is a part of P. So this is the part symbol of a power diode. So this is you know, this part arrow marks, all these fundamentals are there. This is called the part P type, and this is called N. And this P plus, I'm writing P plus, just actually part it is heavily doped with the impurity, and this is part lightly doped. You can see this construction of this diode actually include three layers like P plus layer and N minus layer, and also N plus layer. You can see this is P plus, this is N minus, and this is also N plus. So, but in general diode, basically you can find there is a P and N, but in this diode you are getting actually some heavily doped P plus and also the part N plus with a part lightly doped N minus, which is not in case of your part PN junction diode in general diode actually. So this is the part basic constructional difference, or this is a part a complex for complex structure in case of power diode as compared that of a part the general diode. And here you can find this here the top layer is the P plus layer, and it is heavily doped, and the middle layer is part simple N minus layer, and it is lightly doped, okay. And the last layer, that is called N plus layer, which is also heavily doped. So this P plus layer will act as your part anode, and this is a part and this is act as a part cathode. And the thickness of this P plus layer is basically some micrometer order, like 10 micrometer, and the level of the doping is for 10 to the power 19 concentration for volume, or concentration per centimeter cube. So this is the part the doping concentration which is get added to that of the part P plus layer here. Similarly, The N plus layer acts as a part cathode, and the thickness of this layer is found to be 250 to 300 micrometer, and the level of the doping is also part same. That means P plus and N plus both are part same quantity doped. Okay, and the N layer, which is the middle layer of the junction between the P plus and N plus, will act as a part middle layer or drift layer, and the thickness of this layer mainly depends upon the breakdown voltage and the level of the doping, that is 10 to the power 14 centimeter cube per centimeter cube. And once this layer with increases, then the breakdown voltage also part increases. But so every diode has a part breakdown voltage. So breakdown voltage means, so up to what particular voltage it can sustain, and after that the current may be get dropped. Okay, so this is for the constructional point of the construction of the part, how you can make a power diode. Okay, then coming to part working principle, that you can find the working principle of this diode is similar to that of the normal p-n junction diode. Okay, and you can find so before going to part details working of the p-n junction diode, or just like a part power diode, all of biasing is required. So biasing means that is a p type. So means we have the two type. Biasing means we have to add some extra power from the outside. Okay, and this biasing actually basically two type. One is called forward biasing and the other is called the part reverse biasing. So all of forward biasing is simple. When the p type semiconductor is connected with the positive layer, positive terminal of the battery or cell, we call, and the negative terminal is connected to that of the n type, we call this forward bias. And if we just change the polarity, we can say this is reverse biased. So the working principle of this diode is similar to that of the normal p-n junction diode. When this voltage of the anode terminal is higher than that of the voltage of the cathode terminal, the diode actually conduct. All of that means I want to say here, when this will be part highly doped and this also part highly doped, then the diode is highly doped means P will be positive and N will be part negative. Then when you can supply the part battery here, then the diode will be in a conducting stage actually. So the diode will be part conduct. And the range of foreign voltage drop in this diode is very small. Approximately, you can find some 0.5 volt to that is 1.2 volt. And in this mode, the diode works as a part forward characteristic, or that is called the part forward biasing. If the voltage of the cathode is higher than that of the voltage of the anode, okay, suppose in this terminal I will apply some higher voltage as compared that of the part p type voltage, so n type, and I apply higher voltage as compared that of the part p type voltage. So in that case you can find that is called the reverse bias. So reverse bias means when n side is get heavily doped or heavily we apply the part more voltage as compared that of the part p type p side, then you can say this is a part reverse voltage or the reverse bias. Okay, so and this is the part you can diagram you can see. So this is p type, this is positive, and it's a n type the part negative. I told it part when this is the part heavily doped as compared that of the part this n type, naturally the diode in a conducting mode, and the electron, the holes will be the electron will be part move forward to this region, and electron will flow, the hole will part simple move toward this region. And all of that part the current will flow in the part direction of the part hole, but opposite that of the part electron. Okay, so this is how a simple power diode can be act when the power supply is when the power is supplied to that of the diode here. So I told you the part is forward biasing and the reverse biasing. Okay, not to be for repeat there. Then coming to that of the frequency response. Okay, so how this diode actually responds to that of the part, the different frequency of the part AC voltage or the AC supplied that of the part p-n junction diode. So power diodes are basically general, not used in high frequency applications because they are significant charge storage and recovery time. So you can see the general diode can be used for this different frequency, but the power diode cannot be applied to this high frequency application due to their significant charge storage capacity and also the part recovery time. However, they are optimized for low frequency application. One is called that is reverse recovery time, and the other is called the part junction capacitance. So what is happening actually in the reverse recovery time? So this is the part time, the time it takes for the diode to switch off from the conducting to that of the blocking state. That means when you can supply the power, so to operate the diode or to come to the part in an active condition, it needs some time. So this is called the part reverse recovery time, and the pioneers have the longer time, longer recovery time to signal diodes and limiting their part using the part high speed switching actually. Okay, and the junction capacitance which is get developed due to the diffusion of the charge carrier across the part junction. Okay, this also affect the part frequency response or the frequency, or is also response that of the part frequency of the part AC supply. So these are the parts, some of the characteristic of the part frequency supply for the power diode here. Okay, and similarly, if we can come to the VI characteristics, it is just you can see the part VI characteristic general diode and also the power diode almost same actually. So all of you know when you can supply the voltage 0 actually, so the electrons and the whole pair are not generating or not actually produced. But actually when the part of we increase our voltage to a part more and more, then you can find at a certain forward voltage the current actually part goes suddenly rises, and that voltage where the current rises suddenly, we call it actually part knee voltage. And once the part voltage, the material got the part knee voltage condition, the this is increases a part very with a very high value, and suddenly part sharply rises. Similarly, in the reverse bias condition, so this current is actually, so even if that we can increase the part reverse bias voltage or the negative voltage at the end terminal, the electrons may not be part emitted, but at a particular breakdown voltage, so all these electrons are get free, and that is why the current rises also part suddenly in a part negative direction. So this is why you can find the part nature of the VI characteristic of the power diode same as that of the part general diode as shown in the part figure here. Okay, now I'm coming back that of the part some of the applications. So if you can go in the day-to-day life, you can find many applications of these diodes, particularly DC power supply for changing the battery, inverter, AC rectifiers, okay, and also some of the part so snowball network, freewheeling diodes, okay. So these are the part some of the part applications that I mentioned. You may be part get it from the your material also, okay. Now I'm coming back to the part actual light emitting diode. Okay, so what are the part light emitting diode? It is also just one special case of the part the general diode. So light emitting diode, the name signified this diode actually emit the part light when it is get activated. So the light emitting diode is a part simple PN junction diode. It is a specially dropped diode and made of special type of semiconductor. When light emits in the forward bias, then this is called the part light emitting diode. So all of you can see this is the part symbol of a LED, and we just put the part arrow mark. That means it is emitting. So when you can put the arrow mark, actually it is a symbol of a light emitting diode. And this is basically that I told here, the light emits in the forward bias condition, but not in the part reverse bias condition. So if you basic cause of the part in forward biasing condition is part, because in forward biasing condition, almost all the part electrons, okay, which are get actually highly negatively charged, so they may be moved towards actually your part in a p-type semiconductor at the diffusion region or the part the contact potential region. They may be part recombined with the pole, and during that recombination, so they may be generates the part few more photons, okay, and that photons will be simple emitted as a part emits as a light, and which is appears as a part LED that whenever we are getting switch on. Okay, so now the question is part there, how these part LEDs are part get constructed. So the construction of the LED is very simple because it is designed through the deposition of the three semiconductor material layers over a part substrate. That means when over a part substrate, we can put the part materials, or we can put the part N type or P type, or depending upon the color of the light that you want to get, according to that you have to mix a material in a compact form, and in that compact form, since you know that the different layers are having the different composition or the different concentration, so they are actually emitting the light in the different rate of interactions. Okay, so that is why in the market you can find the different LEDs are available for the different color, and sometimes you can find the part the complex LEDs. So means the same LED can execute the part the different both the red and the green, yellow, every type of color, the same bulb as like in the market you can available. You can find the one bulb can show the part multiple color. Okay, because when you can go to the part design or the construction of this part devices, you must find they are made of the part multiple material, and the multiple materials have the different time of the transition, and once different time of transition is there, then actually the different time of, depending upon different time of transition, they are emitting a different color of light. That means we are getting a part different color of light from a single material when they are get excited into different regions actually. Okay, so the construction of LED basically consisting of a part very simple, because it is designed through a part deposition of the three semiconductor or to of semiconductor material over a part substrate, and these three layers are arranged one by one, where the top region is a p-type region, and the middle region is a part active, and finally the bottom region is a part n-type. So that means we have the three different region in a LED. One is called the part p-type region, or middle region is part active, and the last region is called the part n-type. So how actually, so these three regions semiconductor can be observed in the also the part in the construction. If you can see also the part this one. Okay, so here you can find there is a part, this is called the part intermediate zone, and this is the part top zone, and this is called the part that lower zone. Okay, and this is simple basically made up of the part silicon oxide, that is which is heavily doped with the part p type material, and over this there is a part some metallic contacts are part given, and this metallic contact actually responsible to allow the part charge carrier to flow from the part upper region to that of the part lower region, because this lower region is part n-type part semiconductor. So basically that we know the part the current is flow in the opposite that of the part electron, and also flows in the same direction that of the part hole actually. So in the constructional point of view, the p-type region includes the hole, and n-type region includes the part electron electron, where the active regions are include both the hole and the part electron. Okay, and when the voltage is not applied, that means when there is no power supply to LED, then there is no flow of the electron and hole. So so that they are part stable actually, because as there is no flow of the electron hole takes place from the part one region to other region, then actually they will be considered as a part stable. Okay, they are considered to be part stable actually. Once the voltage is applied, if you can see, so when I can apply the part voltage to this region actually, then you must find it will get actually get the, so all these part charge carriers are get activated, and from the p type you can find this for the holes are part coming to this region, and the electron from this region, the electrons to start to flow from this n type region that of the part p type region, making a part a continuous flow of the part current. Okay, so this is the part you can go to the details actually part in construction that here actually. Okay, similarly that how the part actually part LED part actually work. So this construction or this operational of the LED or the part working of the LED can be explained on the basis of the part energy by diagram, as like the part in quantum mechanics. Okay, so you all of you mark actually. So this is actually this diagram actually represents the part. This is a p type region, and this is n type region, and this particular region is actually called the part deflection region. That means where the junction is part get built. Okay, in that region you can find the part deflection region, and the deflection region particularly you are not getting any of the charge carrier, rather all the charge carriers are part simple move to that of the part different regions, to the p to the part n type. Okay, so the light emitting diode, simply we know a diode, when the diode is in photobus, then the electron and holes are part moving fast across the part junction, and they are combined constantly, removing part one another part out actually. So what I'm telling actually, so when this metallic contact actually given to that of the part, both the part upper and part lower layer, so there is actually movement of the part charge carrier takes place. Okay, and you all of you know these charge carriers are simple move from the part high concentration region to that of the part low concentration region. And second thing is part as depending upon the part electrical charge carrier concentration. Okay, so charge carrier concentration particularly determine in which direction the part the charge will be for simple flow actually. So that's when the diode is per burst, so naturally there the electron holes are per simple moving across the per junction, and they're combined constantly, removing the part is one another out from the junction actually. Soon after, the electrons are part moving from the N type that of the P type silicon, it combines the part poles and then it will be part disappear. You can see, so when the part equal amount of photon or the equal amount of the part electrons are part, the electrons and protons are part there, so when they will be combined, then the part system became part neutral. So nobody you can say actually part electrically part neutral, even if that we can say the part they are electrical neutral as per the part quantum as per quantum mechanics, but they actually part move from one region to part other region on account of your part density difference actually. So then what you can find actually, so when the PN junction diode is part forward biased, the barrier width is part reduced actually. So you know this is the part region where the barrier width is actually get fall. So when there is a part heavy interaction, so the width of the barrier junction will be get reduced, and once it will get reduced actually, then actually there is easy for the part the charge flow and that charge flow and also the part current and also for the part current actually. Okay, so this is how, so you can see that means when the part electrons are get jumped from this p type region and to that of the part n type region, within the region actually the part the whole and part electrons part get actually combined or the recombined here. And what happens, so this during the part recombination, that so some amount of the charge will be, or the sum of the part energy converted out of the part heat energy. So that is why you can find when of the part any of the part instrument operate for a long time, they may be get part radiate the part heat, and in the same time you can find there is also you can find yes some light actually some light is also part emerging due to the combination of the part electron hole at the junction region. So that means when one of the part any or when there is a recombination takes place continuously, there is some heat is produced, and also that you can find some light surface get produced, and this is on the basis of that LED is per simple operating here. Okay, now so working of the part LED that I have already part told you, and this is the part concept actually. You can see this N type and the part P type here. So here we can find, so the holes are per simple, so electrons are per simple move from this region to part this region. Okay, and and uh, and this is the part, and if we can connect actually for this is the part simple the voltmeter or maybe part a cell actually, and that cell actually helps in movement of the flow of the part charge carrier from the part other region. Okay, so this is the part the constructional details structure given. Okay, then you can find the light emit diode in a part circuit for biasing actually. So as we have discussed actually biasing in case of a power diode, similarly the you can find also the part yes biasing of the part this part light emitting diode or part LED actually. Okay, so you all of you know the part most of the LEDs have voltage ranging from the part 1 to 3 volt. So almost all the part LEDs are actually consumes of part very less power. So that is why in almost all cases you are using for this LED. Okay, so there are part some of the regions or some of the applications you can find these LEDs, particularly part in 7 segment display and any display board, and also for the different type of making the sensing of the for different device the signal sensing element for the different cases. Okay, so and these are the parts some of the part outline. So how to be part get biased I told here. So this is a part of a PN you can see voltage, and it's a part PN junction, and this p type semiconductor is a part simple get actually connect is maybe get actually part heavily biased, and due to that biasing the charge or the charge and the part the current maybe part get flow through the part circuit actually. Okay, and during or using for such properties, now this part LEDs are actually part used in most of the part cases. Okay, so these are the part some of the applications that I mentioned here, you may read here. Okay, then coming back to part IV characteristics. Is the slide is visible?
Yes, sir.
Yes, sir,
Yes,
visible.
sir.
Okay. So then you are coming to the IV characteristic of the pod LED actually. So if you recall back actually this PN junction diode, you are getting a forward biasing and the reverse biasing. But in case of the pod LED, you can find, you can see I put the part the different color. For this is infrared, this is red, this is for the orange, this is the for blue. And here since the diode is operating only or the LED is operating only in forward bias condition, so there is no need to actually get the part that is a reverse biasing. Only it has a forward biasing characteristic. And then the same procedure, that means when there is a recombination of the part electron hole takes place, so at a particular voltage you can find that they have a part new voltage, and again they have this voltage are part simple or the at that particular voltage currents are part suddenly rises. And this is the part since you are getting actually or since the LED is operating due to the part some external power supply, because already it is forward biasing, so naturally we can use the part different color of light, and accordingly they have the part different output structure, output of the part IV characteristics here. Okay. Now I'll similarly the frequency response of the part LED. So that is so this LEDs actually operate in the part the different in the different situation, like a part modulation speed. It has the part the bandwidth, capacitance on the parasites, and lots of the part materials. Okay. So frequency response, because the frequency response of the any of the part devices are actually affected by the different factors. First is the part rise time and also the part fall time. Rise time each part and fall time each part actually. So this is the time it takes the time it takes for the LED to increase from the 10% to 90%. That is called the part of its part maximum intensity when switched on. So any LEDs actually get the power consumption from that of 10 to 90. Okay, we call it part the real time. Okay, and this fall time is part if the time it takes for the LED to decrease from the 90 to part 10% of its maximum intensity when switched off. So in both the cases rise in somewhere rise and somewhere is part get actually the part fall time, but this all this part rise and fall time occurs in a occurs in the part also part LED actually. Okay. Now, coming back to the part bandwidth, actually, the modulation bandwidth of LED is inversely proportional to that of the part rise and the fall of the part time. Okay, so that means here you can find bandwidth actually part inversely proportional to that of the yes, you can find important that of the part rise or the fall of time here. Okay, so and the higher the speed of the part, high speed LEDs are actually can have bandwidth up to several hundred, that is part megahertz. Okay, and making sure them suitable for the optical communication system. Okay, then now coming back the per capacity the per parasites actually. So junction capacity of parasitic in the parasitic inductances can limit the speed at which uh, is at which and but LED can be part modulated. Okay, and the high speed LEDs are actually designed to part minimize the part this defect actually. Okay, and these are the parts of material which may use for the part construction of the part LED actually. Okay, now coming to the part actually for application for LEDs. So these are all. So nowadays you are looking to the part the different LED circuits for operating LED circuits for different purposes. Okay, so these are the part some of the part design how the part LEDs can be part arranged to get the part is to proper light or the part proper intensity. So this is the part theme or depending upon for that theme there are part many applications of the part this of this LED. Okay, so this is the part some of the applications of the part LEDs are here. Okay, similarly, and coming back that of the part laser diode actually. So you have read the part p junction diode, you have read the is a power diode, you also you have read the is this LEDs. Okay, now we'll come back. We'll come to the part laser diode actually. Okay, so what is the part laser diode? So as like a part similar that of the part LEDs. Okay, so the laser diodes stands for the part light amplification by stimulating emission of the part radiation. Okay, so naturally So it is a semiconductor based p-n junction device that converts the part electrical energy into part high energy similar to part LED actually. Okay, and it generates a part high frequency constant and also the part monochromatic light actually. So that is why due to such features we are using the part laser diode in many of the part instrument design and also the part devices actually. Okay, now the question is there how to part simple work actually. Okay, so when the p-n junction diode is power burst, this electron from the part a region and holes from the p region across the junction and also the part recombine the part each other actually. What I'm telling actually, that means this is based on the part principle when there is a recombination of the part electron hole takes place, and from that actually you can get the part ideas about the part how it is get operated here. Okay, now come at the part construction. So it is same as that of the LEDs. Okay, and in that LEDs or in that actual construction, you are getting actually very simple. There is a P-type layer, N-type layer. There is a part interfacial layer, and these are called the part laser diode. Okay, so now 1 minute. Is the slide is visible?
Yes, sir, visible.
Yes, sir, visible.
Yes, sir.
Okay, is it visible now?
Yes, sir. Yes, sir.
Okay, okay. So let me put yes. Hello.
No, sir, visible.
Is the slide is
Yes,
moving
sir,
now?
visible.
Is the slide is moving?
Yes, sir, it is moving.
No, sir.
Okay. See?
Side
So
is visible.
okay. So if you come to the actual part laser diode, all of you can see. So this laser diode actually, the word laser, all of you know, that is called the light amplification by stimulated emission of radiations. And it is a semiconductor based p-n junction device that converts the part electrical energy into the part light energy, similar to that of the part LED. So you can see light emitting diode, but this is called the part laser diode. So difference is part actually. So it is generates a part high intensity coherent and monochromatic light, the laser diode. But uh, just if we can go to the part LED, actually it is simple, emitted the part light due to the recombination of the electron hole. Okay, but it is generates a part high intensity coherent beam and monochromate light. And if you can see the first symbol, actually this is the part. So now these laser diodes are actually used for the part many of the part sensing instruments. Okay, just like in a part TV remote, and also the sensing devices like in the in your TV, and also the nowadays if the fan is coming also for the remote control. Okay, so these type of diodes are part particular part used here. Okay, so this is the part symbol. You can see these are the part, the symbol of the part, this laser diode, where you can put the part that this arrow mark. So this indicate the part symbol emitted here. Okay, and if you can find actually the part, the different components, if you can see, this is called the part the stem, and this is called the part sub. So these are the parts, some parts you can see there. So what is the basic principle actually? When the p-n junction diode is forward biased, okay, the electron from the n region and the holes from the p region cross the junction and recombine with each other. The simple, the same way, just like in a biasing condition, from p type the holes are moving, and from the n type electrons are moving. They are recombined, okay, and they can produce a spotlight. So during the recombination process, the light radiations, the radiation means there is a part photon. All of you know, as is a very fundamental the part photon means the photons all are present in the part present the part light. These are called the part light particle, the quanta of energy. Okay, so they are actually produced when there is a recombination of the electron hole produced. Okay, from a direct band gap semiconductor like gallium arsenide. Okay, because gallium arsenide is one of the compound semiconductor. Okay, on which is part used to make the part laser diode actually. So this light radiation is known as part recombination radiation. Okay, then we come to part construction. So here you can find actually the construction that is actually part is this is upper similar to LED, and it uses upper gallium arsenide doped with the elements such as selenium, aluminium, silicon to produce the part P type and part N type. That means gallium arsenide is simple doped with the first source material. It produces a part this LED. So this produces actually part a laser diode. Okay. So while a laser diode has an additional active layer on doped, okay, there is on doped intrinsic gallium arsenide above actually. So you can see this layer actually part a on doped layer, that is a pure gallium arsenide. This is pure material, pure gallium arsenide, or that is called the part intrinsic. Okay, have the thickness only a few nanometer and sandwiched between the part P and part N layer. You can see. So this dotted line actually this is called the part intrinsic gallium arsenide layer. Okay, and this is get sandwiched between the part P type and part N type layer. So what happened actually? So when you, so this is a part construction point of view. Okay, and in this layer the laser actually part produced. Let me go to the part actually the working. So if you go to working, what will happen? So as I've already told you, the P type is called the positive and N type is called the part negative. Then actually when the power is supplied, so from P type the holes are part moving towards this junction, towards this thin layer, and also electrons are also move towards apart this thin layer. And the recombination process takes place within the part this P intrinsic gallium arsenide layer, and that recombination produces a part laser light. Okay. So now how it can work, you can see this is the part diagram. This is the part called the quantum mechanical actually part actually the quantum mechanical presentation. This is actually the part the Fermi energy bands, conduction band. This is called the valency band. Okay, and in this region you can in the P side basically you know the holes are part 3 holes are there, and in this N side actually you can find these are the part rich in the part electrons actually. Okay, so when there is a biasing takes place, so this electron will be get penetrate from this N type region, and the holes are get also for attracted toward this region, and within this region actually we can find there is recombination takes place. And all of you know when there is a recombination takes place between the hole and the part electron, we can find it will be just looked out as a part laser light, and this is the part band gap. So depending upon the part different band gap, you know, the different semiconductor materials have the part different band gap, but like germanium and silicon, similarly, just we are trying to, by adding the part some of the DOF material, we are just going to decrease the part band gap. And if we can go to decrease the band gap actually, then there is easy transition of the part electron and hole takes place, giving the part more and part more light. Okay, so this is the part written companies, the details actually forward bias and also the part reverse bias condition. I'll go to the part again. So, and you know, depending upon the part band gap, you know, this is the basic formula, how much light will be produced and what is the wavelength of light produced. It can be determined by this formula, because Eg means band gap is equal to h nu, and nu is equal to c by lambda, that is hc by part lambda, and from this lambda you can find hc by part Eg. That means, so we can calculate the wavelength of light. What is the wavelength of light that is coming out by, because h is a Planck constant, c is the part simple of part wavelength of light, sorry, the speed of the part light, and this is the part band gap may be given. Okay, then immediately you can calculate the part this wavelength. So in a particular cases, as you are using gallium arsenide, so light photon, so does the light photon grow in the first strength, and after gaining enough strength, laser beam of wavelength of 8,400 angstrom emitted from this laser diode actually. Okay, so this is the part formula on the basis of which you can calculate the part, the wavelength of a given material. Okay, now, so coming to the part biasing actually, similarly, laser diodes are part typically operated under forward bias condition. The biasing is simple, involves applying a voltage across the PN junction to inject carrier into the active region. Okay, so just so as like a part LED, it is also operating upon the same forward biasing condition. Okay, and you can find actually so the proper biasing is actually the critical issue for all type of laser diodes. If the laser diodes are not properly biased, so you may not be get the part laser light emission actually. So that is why while you are making biasing, so whether they properly biased or not, or the proper voltage is applied or not, that you have to be part C during the part construction. Okay, and accordingly you can find, so this biasing can produce the part the two different parameter or the different quantities, like one is called threshold current and the other is called the part above threshold of operation voltage actually. So what is threshold current actually? You know, threshold current is a minimum current at which the current must be exceed to the achieve the ledging action. That means what minimum current that should be allowed to or to be supplied to the part material, so that it can be get actually, so electrons are get excited and get ready to the part to achieve the part ledging action. Ledging action means that emission of the light at a particular part at a particular activation state actually. So that is known as a part ledging action. Okay, similarly above threshold operation, once the threshold current is part reached, increasing the part current further increase the output of the part power of the part laser. So once the threshold current is part get obtained, or the threshold conditions get obtained, then current is part to further increase of the current we don't need, because once the threshold current is get achieved, the all the electrons are get become free, and these free electrons now achieving the part that for high current. Sometimes it is also for maybe also for put some problems, but to minimize this loss or to minimize this actually excess current, there is some layers are given which may absorb the excess amount of the part electron actually, so that the device can be operated in a part in a safe mode. Okay, so this is the part, some this is how the biasing actually performed for proper operation of the part this laser diode. Proper biasing is also part a required condition. Okay, so now coming to the part actually VI characteristics actually. So this VI characteristic actually shows the relationship with the voltage. You can see this is a voltage applied here, and this is a part current actually. Okay, and laser diode is essentially a PN junction diode. I have told very many times, having junction voltage drop called forward voltage, or this is called the part knee voltage, at which it is actually rises very suddenly. And most laser diode has a 1.5 volt. You can see this is a 1.5 volt is actually the part knee voltage or threshold voltage, at which the current rises actually for sharply. So for almost all the laser diode, this is kept constant actually. Okay. Now you can find the frequency response also of the laser diode that indicates the per output power varies with the part modulation frequency of the part input current. So that means so this laser diode also respond to that of the per different frequencies. Okay, and these are the and this also there are this they also decide some of the factors like modulation bandwidth, relaxation of the oscillation, high frequency performance. So all these parameters actually uh, get influenced by this frequency response of the laser diode. Okay. Now I put the part some of the characteristic of the part laser diode. So this laser diode actually you can find uh, is you can find actually for this laser diode. Is it visible to all? Hello.
Yes, sir.
Yes, sir. Visible.
Okay. So you can find
Yes,
if
sir.
you can. Hello. Yes. Anyone wants some questions?
No, sir, it's visible.
Okay.
I just replied.
Okay. Okay. So when you can actually go for the part design of the part any of the part laser diode, so these are the material has there are part some input and also there is some boundary conditions like you can see. So type is part actually for making part this laser diode you must need solid state semiconductor laser. Solid, so this is actually all the laser diodes are basically solid state semiconductor laser, because I put the part gallium arsenide as a part simple the intrinsic layer between the p type and n type, and this gallium arsenide actually produces a part laser light due to the recombination of the electron hole inside it. Okay, and active medium I told you part I put the part gallium arsenide here, and pumping method is called the direct conversion method. Direct conversion method means so you are using the part current directly to the part p type and n type. There is no other via medias. We are directly put the part electric current for activation of the part medium. Okay, that is called the part pumping method. And the power output we are using actually some milliwatt. Okay, then the part nature the output you can get you are getting continuous output, not actually pulse. Okay, and wavelength of the laser is found to be that is 8,300 to 8,500 angstrom. Okay, and there are some advantages of this laser diode. You can find they are very small in size, compact, high efficiency. Then you can find also there is not putting actually part any pollution to the part environment, that is called the free of the for carbon dioxide, little additional equipment with less power requirement. Okay, but at the same time it has some also for disadvantages like the laser beam which is get actually emerges out, it is not actually that much coherent, so it is get diverse. So that means we cannot use this laser diode to be operate for a long distances, because it is because for any of the large distance operation we need actually what coherence or the for actually convergent beam actually, so that it can produce a point beam with a high intensity. But this output beam have a divergence. Okay, and the purity and monochromatics are very poor. That means sometimes you can find I just told that it is associated for different frequencies and also wavelength, so it is not actually giving a monochromatic condition, and it has poor coherent and also the stability. That means the phase of the particle are not found to be maintained throughout the propagation of the part light. So this is called the for pure coherence. Okay, now I'm coming to the part some of the part applications you can find. So particularly this laser diode is used for the part optical fiber communication system. That also when you are going to market for any of the part, the part now these laser diodes are particularly used for the barcode reading. So any now you can find in the part market or the any mall all the part that all these part items are get actually associated barcode, and when you can put the part laser sensor to that, this can read out the part barcode, and this barcode can put the part every information about the product. Okay, so these are the parts some of the applications that I mentioned here. You may be part read or you may be go through details actually. Now I'm coming to the actually for solar cell actually. So this solar cell actually you all of you know nowadays you are almost all are part using actually the part solar cell. Okay, So this solar cell actually sometimes known as a photovoltaic cell. Okay, a photovoltaic cell or photovoltaic cell means it is a simple operates on the basis of the photoelectric effect, and basically the solar cell is a PN junction diode. Okay, and the solar cells are the form of the photoelectric cell. Okay, and individual solar cells can be combined to form modules. You know that the solar modules or the solar panels are a combination of the large number of the yes, this solar cells. Okay, you know there is this nowadays you are getting actually the solar panels. So if we go to the first solar panel, that solar panel consisting of the that large number of solar cells actually. Okay, just like a small point like structure, and within that structure you are getting both the semiconductors are there actually. Okay, and the common single junction silicon solar cell can produce a maximum open circuit voltage that is actually 0.5 volt, that is 0.6 volt for a single. Okay, but if we can combine most number of the solar cell, then you can get also the our required voltage. Okay, so construction of a solar cell actually basically it is consisting of is a junction diode. Okay, so it basically consisting of the junction diode. Okay, and you can find also a very thin layer of p-type semiconductor is grown over the this you can see the diagram actually. So this is a diagram you can see. Okay, so you can see this is called the front electrical contact, this is called the back electrical contact, this is the p-type layer, and this blue color is given actually n-type, and you can see there is a just a deep red color is here. This is called the deflection zone, and there is a metallic contacts are given at the top and the bottom, and from this you can find the electrons with the s. The electrons actually this is as a p-type here, and it's n-type. Then actually the electrons should get flow from this side to the to this side. Okay, and so for every emission of the electron, there is large number of the holes are created, and since again that we are also reach the material with the help of the p-type material, then naturally so this flow takes place continuously. So everything, so this is the actually the construction details, and similarly I told also the this what you call actually your how does it work actually. So all of you can see that when the if this is the actually this is the a solar cell. So when the photon or the light energy get incident, so this photon actually responsible to interact with the this electron which is available in the n-type material, and each photon is responsible to emit the electron or activate each single electron. So when there is a last beam of light is get incident, so almost all the electrons are get excited and get activated to make a transition from their lower level to upper level, and they make the electron to be flow from this surface to that of the other surface. So as that is, you all of you know, when there is a flow of the electron takes place from one closed region to other, so it constitutes the electric current, and this is how we are getting actually photo current in a solar cell actually. Okay, am I actually clearly audible to all of you? Yes.
Yes, sir. Clearly audible.
Yes, sir.
So are you getting my points what I'm talking?
Yeah, I'm getting, sir.
Yes, sir.
Sir, will you share the PDF in WhatsApp?
Yes, I'll be sure share the PDF at the end of the class. Okay, sure,
Thank
no
you,
problem.
sir.
Okay, don't worry. Okay, so this is the total the working principle of the solar cell here. Okay, now I'm coming to actually the the VI characteristic. You can see this is also peculiar VI characteristic of the solar cell. Okay, so if we this is a PV current, or this is called photo current, and this is called the photo voltage actually. So one thing we can mark, students, that when we are increasing the voltage, you see what I'm telling actually, because you know, in a solar cell actually, even if there is current is so the whenever light is also not incident, then you can, due to the some internal mechanism. Internal mechanism means So as there is a moment of the randomly moment of the electron hole takes place inside the part, this semiconducting material. So it is always in a part in a recharging condition or in a part in active condition. Then actually when you can voltage zero also, you can get some dark current. Okay, means what is some dark current is there, and so even if there is a zero voltage is there, this may be some potential and it has also some current actually. So when you can increase the part voltage actually, then this will be part actually what is get highly and part highly energized, and also it get actually part give the part more flow of the electron hole takes place, and which for which you are getting a part maximum value of the part current. This is called the part maximum power output, because voltage and the current P is equal to VI. I can get the part maximum power here, and after that so when every material having a part a decomposing state, when because it can operate for a particular period, and after that its efficiency goes on decreasing, and throughout the part the entire life cycle of the part the solar cell, this is the part characteristic curve that you can obtain actually. Okay, then coming back to the actually, so what type of material that we should choose for constructing the part for this solar cell actually. So all material are not to be good for the part solar cell. So the material which is to be good for the part solar cell, having they possesses the part some of the properties. Particularly you can find the material which is to be used in the part solar cell must have some distinct point actually. Okay, so what are the different distinct point? If you can see, that is called the part, you can see material used in solar cell must possesses a band gap close to that of the 1.5 eV. So can you tell me what is the band gap for the silicon? Hello? Yes? Hello?
Yes, sir.
So what is the band gap for the silicon actually? It may be part nearly 0.74, and for the germanium it is part 1 actually. But you can see, even if whether germanium or silicon, so we should choose the material in such a way that it is close to that of the part 1.5 ev. Why 1.5 ev? Because when you can actually operate of the part any part dry cell also, there is also part 1.5 volt, and here we are giving 1.5 ev is a band gap. 1.5 ev is a part energy band gap, which also part is a, as compared to that of the silicon, it is very high. But if we can make actually close to that, then this material may be part good goodly or the part the best suitable for also making the part the solar cell actually. Okay, so and here you can find electron efficiency also good, and the commonly used material I told already, silicon, gallium arsenide, that is cadmium, tellurium, and also for copper, indium, selenium. Okay, these are the all materials which make the best fit for the part making solar cell actually. Okay, and not all material I can select the uh, for making solar cell. So there is some criteria here. So what are the criteria? It must have band gap from 1 ev to 1.8 ev. Remember, 1 ev to 1.8 ev electron volt. Okay, it must have high optical absorption. It must have the high electrical conductivity. The raw material must be available in abundance, and the cost of the material must be part low. So these are the part some of the criteria for selection of the materials to be used for the actually for making the part solar cell. Okay, and these are the parts some advantages I put actually for this solar cell, and some disadvantages. And nowadays actually you can find almost all you can find the solar cell actually for having high applications in the part nowadays actually, because almost all the things you can find that all are part made up of the part this solar cell actually. Okay, so if for example, for particularly for the charging of the battery, light meters, and also the power calculator, wristwatch, spacecraft. Okay, so all these are part. These are the part some application of the part solar cell here. Okay, now let me go to the actually part this. Uh, Then how this actually solar cell. Okay. Yes. I let me put actually some last view actually, so that I maybe just 1 minute. Okay. You can see here. So as already I have told you here, this solar cell actually. Okay. So there is also 1 minute. Okay. Huh. So, so the mechanism of the solar cell actually, let me put detail explain here. Though I told the part some of the compact design or the compact explanation to that. So, if you can go actually for this energy band diagram, okay. If you can see this is a part P type and this is N type, and this middle layer actually a part your gallium is gallium arsenide. And I told the part when there is actually the flow of the part charge means for the light is get incident here. So you can see this whole part simple moving towards the part this junction region means this gallium arsenide here. Okay, and the electrons are also part simple moving part towards this actually. So there is a recombination of the part the charge carrier takes place, and in the same time you can find there is a part decrease of the part the bandwidth or the decrease of the part this which takes place, so that to easily facilitate the recombination. Okay, you can read also part these things. Everything I have already explained the part in the above. So I put also in part some of the energy diagram here. Okay, you can get it here. And this is also another part the same vi characteristic I told here. This is for vi characteristic, the same vi characteristic also for I have done here. And you can see that with increase of the voltage how this part actually current is also part goes on for increasing here. Okay, and the different power output also you can find for the different voltage and the current corresponding current. And this is I put it here the maximum. So how can you calculate the part efficiency of a part solar cell? So so efficiency of solar cell actually is defined as the part the ratios of the part total power converted by the solar cell to that of the total power available for energy conversion. Okay, so that means this is the part efficiency because depending upon the your requirement actually, nowadays actually the government is actually providing for all these for solar cells. So for every 2 to 3 members of the families, okay, there is a part particular dimension of the part this solar cell. And this solar cell so depending upon the part your requirement you may use the particular size of the part solar cell, and that solar cell efficiency so depending on your requirement you can so how much size of the solar cell that you have to use, and you can calculate part by calculating the part this efficiency of the part solar cell for how much the size and the shape of the part solar cell actually. Okay, so this is the efficiency of the part solar cell that you can calculate here. Okay, now I'm coming back to that actually your part photodiode actually. Okay, this is student this it is also part a special type of PN junction device that generates a part current when exposed to the part light, and that is called the part photodiode. And that photodiode sometimes known as photodetector or photosensor. So here in all the solar cell that you can find this arrow marks actually part towards outside or towards outward direction, but here you are getting actually for inner actually. Okay, and this is simple converts the part light energy into electrical energy. Okay, this is just a reverse of the part LEDs actually. Okay, and here you can find the principle. It works on the principle that of the photoelectric effect, and the operating principle of the photodiode is such that when the junction of these two terminal semiconductor device is illuminated, then the electric current starts flowing through it. All of you can see that if you can go to for diagram actually, so you can see actually this is a structure of a photodiode, okay, and this is called a P region and say N region, and this is the part junction or the deflection region. This is a part anode, this is a part cathode, and this is the part diffusion marks for the part silicon oxide or silicon nitride coating. So where you can give the part metallic contact here, and this the radiation coming from the part sun get incident over the part this region, and once the radiation get inserted in the P region, so it will help the part displace the part holes or activate the hole, and that hole may move towards the part this N region, and holes are actually part holes are moving inside the material, but actually the electrons are get transit from this region to part other region. Okay, so here the same things are written. It works on the principle of the photoelectric effect, and the operating principle of the photodiode is such that when the junction of these two terminal semiconductor device is illuminated, then the electric current starts flowing through it. Only majority current flows through the device when certain reverse potential applied to it. So, but in normal condition, the normal current is flowing. But when these situations get arrived, there may be heavy current flow. But this situation is very real or may not be part occur actually. Okay. So this is the first structure I told here. The PN junction of the device is placed inside a glass material. So entire this PN junction will placed in part glass material, and this is why you put in the inside the glass material, because this is done to order to allow the part light energy to pass through it. So because if a glass is there, so when the radiation get incident, then easily it get absorbed and allow the part light to be passed through and allow to incident over the part P region here. Okay, as only the junction is exposed to the radiation, the other portion of the glass material is painted black or is part metallized. Okay, so the overall unit of the very small dimension about 2.5 millimeter. Imagine, it's very small. It is noteworthy that the current flowing through the device is in microampere, not some ampere. It is per microampere, like part 1 microampere, 2, 3, 4, like that. Okay, and is measured to the per ammeter actually. So it is maybe as a part very small current, we may be use upon this ammeter actually for this measurement here. Okay. Now coming to part working of the part photodiode here, you can see this in this photodiode, a very small reverse current flows through the part device, that is termed as per dark current. Remember, I told you very before, even if that we are not allowing the part in light to be incident on the part this photodiode, there is some internal mechanism takes place, and that internal mechanism, or there is always the recombination randomly orientation on the part electron hole takes place, and that may be produces of a dark current actually. It is called so because this current is totally the result of the flow of the minority carriers, and is thus flow when device is not exposed to radiation. Remember, this dark current will not appear even if there is no radiation get incident from the sun, then that dark current part exists. Okay, and this is the part you can see nicely. This is a N region, this is a P region, and this is the part cell, and this is called the part deflection region. And in that deflection region, you can find the part same number of electron hole pair actually for get combined. Okay, and you can find this electron present in the part P side and hole pair in the N side are the minority carriers. You can see even if the part N side, I can find there is some of the part electrons, and even if they are P type, this we can find there is this white spots are basically termed the part hole. So you can find so when there is some hole in the P type, hole on the part in the N type, and some electron in the part P type, there is always a part created part density difference and also the part potential difference, and that potential difference helps to move the charge carrier from one region to other region. Okay, making the part substance become highly active and getting produced and producing the part current, that is called the part photocurrent. So this is how, and this current is very small, some microampere. Okay, and we can measure to also part ammeter here. Okay, this is the part working the photodiode here. Okay, now the same things already part I described here actually how this will operate here when the so here you can find yes, The same thing that I put it here to be given the part details. Actually, you can read here. Now, coming to the part characteristics of the part photodiode here. So, what are the different characteristics of the photodiode? So, because as we have to read out the part VI, because for a particular, for particular the voltage, how the part currents are actually get generated. So, you have to produce this. We have to draw the VI characteristic or the VI response of the part, each of the part diodes, and you are finding here. This is the part VI characteristic of the part photodiode here. So this is called the part because as I already told, the dark current is there. Even the current is part not there. There may be part some. It may be produces some. Even there is no part external radiations, but there is some current and voltage exist. That is called the dark current, and you always operate the part in the reverse bias condition here. Okay, just you can see that when the voltage actually part increases actually negatively, the current is also part goes on part like that. Okay. So this is the part peculiarity you can find. This is for dark current, and when this voltage is goes on for increasing, you are getting a part the current corresponding increase in current at each and every time here. Okay, so this is the part the nature why it will be part current actually, because once the part electrons are get emitted and get start to recombine, they will be produced a part or the recombination process takes place continuously, and you are getting a part saturated current at all time for all voltages for different negative current actually. Okay, yes, am I clear to all? Hello.
Yes,
Yes,
sir.
sir.
Okay, now so if you can go for some of the advantages, it shows a quick response when exposed to light, because whenever you can take the part this the photodiode to the part the sunlight, it immediately respond actually, because why it happen actually, because with the existence of the dark current, there is always immediately there is a part emission of the part electron takes place to the junction region. Okay, similarly photodiodes offers a high potential speed, it provides linear response, and also part a low cost device. It is a part it's cheap, its values per or cost is per very part actually less actually. Okay, similarly these are the parts some of the disadvantages, and these are the parts some of the applications of the photodiode that you can find it here. Okay, like particularly photodiodes majorly find using part counters or switching circuit. Counters means suppose there is a part a confidential room and we are using actually for some of the part display, and all the display actually operating through the part these photodiodes. So they can be used as counting devices, switching devices, and extremely used in optical communication system. Then for making logic circuits for electronics. Okay, then also for typical for the part they have the part actually application also in the part in the designing of the part different spacecraft also for the power absorption. Okay, so these are the parts some of the part applications here. Okay, now after getting the part actually this what you call different diode means you are now we have discussed about power diode, LED, laser, solar, photo, and other is called the part that is called character diode, or you can get actually variable capacitor, but through the different diodes. You can see the part these are the varicap means variable capacitor diodes. Okay, so character diode, or sometimes we call the varicap diode. So a varactor diode known as the part names varicap diode or varactor diode or tuning diode. Okay, so these are called tuning diode. So it is also a part PN junction diode and act as a variable capacitor under varying reverse bias voltage across the part terminal. Okay, so these are the part terminals here. In other words, it is specially designed semiconductor diode whose capacitance at the PN semiconductor junction changes with the change in voltage applied across its terminal. So one peculiar thing you can find, it actually, when you can go to the detail of the construction, there is one capacitors also get developed at the junction layer. Okay, that is why we call it actually variable capacitor or varicap. Okay, and because of the diode that can behave as a variable capacitor, and it is named as part varactor diode in short. Okay, now so this is the part three different type of symbols of the varactor diode, but most of the time we are using the second one as the varactor diode. So it may be a varactor diode. All of you don't confuse yourself. This is these are the different symbols of the varactor diode. So this is one symbol, this is one symbol, this is another symbol. So all have the part anodes and all have the part cathodes. Okay, this is the part symbol that so it is mainly used to replace the variable capacitors that need to be operated mechanically for changing the value of the capacitance. Okay, and the one advantages of this capacitors of the varactor diode can be changed just by changing the voltage across the terminal. So if we can change the voltage across the per terminal, then its efficiency and capacity also part goes on for changing. So among these three symbol varactor diode, the second symbol is what more frequently used. All of you remember. Okay, it is a combination of the symbol of p-n junction diode and a capacitor. You can see this is a p-n junction diode and also for a capacitor. Okay, and in the symbol the triangle indicates actually the presence of the diode component, and the two line it indicates the part parallel line of the per capacitor. Okay, so you can either you can represent either this one or this one or this one here. Okay, now how to be get constructed actually. You can see this is the variable capacitor diode. You can see here. So these are the part that p-type or n-type material. You can see p-type and n-type material. This is for simple a gold plated wires. Okay, and this is gold plated molybdenum for stored. Okay, and here you can find actually this is gold plated molybdenum for cathode. Okay, and one thing you can just mark. So within the junction region, a variable capacitor is also for get developed. Due to this development of the charge carrier are the two different plate, so the system can act as also part capacitor, and these capacitance can be changed with the change of the voltage. That is why we named as a variable capacitor or varicap. Okay, so when both the layers are combined, the different regions are get. You can see the variable diode is a p-n junction, and that form combine the two layers of the semiconductor material, p-type and n-type semiconductor. And when both the layers are combined, a deflection region is get formed in between. Already that I have discussed in many cases. The deflection region is free of charge. There is no charge is available. That means how many number of the part positive charge there, the same number of part electron. So when they recombine, there is no charges there. Okay, but the deflection region does not allow the flow of these carriers unless a potential is applied. So a deflection region never allow any type of charge carrier till a potential if a potential is not applied to that actually. Okay, and the main difference between a conventional p-n diode and that of the varactor diode is that a conventional diode has uniform doping concentration, while the doping concentration of the part varactor diode is part lower near the junction. If this is the part near the junction, then you can find doping is part very low. Okay, and it increases as you go towards the outer terminal. That means the doping region or doping concentration simple goes on part increasing from the junction region to that of the part outer region. Okay, and that is why it has the part, it plays the role of the part variable part capacitor. Okay, now you can see the p-type semiconductor, n-type semiconductor is constructed. That the things I have already told you. Okay, the gold plated molybdenum slots are connected in the n-type and also p-type for making contact potentials or to develop the contact potentials. Okay, and then the working. So coming to the part working, a varactor diode is designed to have variable capacitance that varies within the applied reverse voltage. Therefore, it is necessary to understand the working of a part variable capacitor, as it is a combination of both the part diode and also part capacitor. Then naturally it is the operation is part complex, but it is quite easy or interesting also. Okay, see, so this is the part region when there is a variable capacitor not biasing here. So here you can find a junction or the deflection region is formed and there is no charge carriers are available. But you can find when a voltage applied across, that is called forward bias voltage. When I apply the forward bias voltage to this junction, the recombination of the part electron charge carrier hole and the part electron takes place, for which there is a part there is a region is part get developed. One type became positively charged and the other type is part negatively charged, which act as function of a part is variable capacitor. The same thing that I written. In the similar way, when I can apply the part reverse bias voltage, you can find these charges are get accumulated in p type region and also electrons are get also in the part n type region, but this region again is part get free. Okay, so this is how you can see there is no charge or the no zero capacitance here, the part maximum here is again zero. Okay, this is how the capacitor part gets changed actually here. Okay, the same things are written actually part yes clearly to be part actually the things whatever I written here actually you can see a capacitor has two conducting plates separated by dielectric medium where one of the plate is connected to that of positive and the other is connected to that of the part negative voltages. As the dielectric medium does not allow the part the flow of the part charge, the charge accumulates in the part surface of the part plate, that is known as the part capacitance. You know the part amount of charge stored per unit volume, that gives the per idea of the per capacitance or basic concept of the per capacitor actually. The same thing also happens in case of your part variable capacitors. Okay, so now you're coming to the part yes. Okay, okay. Now I'm coming to the part the characteristic of the part varactor diode actually. So the characteristic of shows means when you can see as you are talking about the capacitance of voltage. So I put the per capacitance not now the current and voltage, rather you can discuss about the capacitance voltage. So this is as variable capacitor or varactor here. So that is why we put the per capacitance and voltage here. So just you can see when there is actually the voltage is part low, there is no consumption of the part charge, okay, of the voltage, and it has the part energy storage part maximum half CV square. But once the part voltage is get actually consumed or the part get utilized here, this storage storing of capacity part goes on for decreasing. Okay, so naturally you can find there is a decreasing trend of the part this energy storage, but somewhat the total energy of the part this capacitance part simple remain constant actually. Okay, so depending upon the charging and discharging, you can find there is a part this may be very or this may be stiff decreases slowly or the part also rapidly. Okay, so the graph clearly shows that the capacitance is clearly shows the part the capacitance decreases with increase in the part reverse voltage. Okay, and this is due to the increasing junction with to the part upward voltage actually. So as the junction voltage actually part simple increases, so naturally part the capacitance also part goes on part increasing. Okay, so now I'll go back to the part or come to the part simple application side. So varactor diode is mainly used in part variable capacitor as its cathode and anodes are part used as a conducting plate, and the reflection region acts as a part dielectric medium between for them actually. However, they are used in multiple applications where some specific regions are there. Particularly, it is used in tuning capacitor that is replaced by the old style mechanical tune capacitor in television for radios.
Sir, what are the
Yes.
advantage of variable capacitor in
Yes, sir. I'm telling. Actually, I'm just putting that advantages. Let me tell. I'm not mentioned, but let me tell actually. So, advantage of the variable capacitor of that variactor is part. It can act both the function of a diode as well as also per capacitor. You can see diode can simple convert or convert a part if AC to DC actually in a rectifier circuit, or can perform some other function. But in this capacitor actually you can find very careful that it can store energy actually. Okay, so this is how it is completely different from that of the part that diode. And the advantages of the part, it can be used in part multiple purpose, multiple the basic need is part it can use in part multiple purpose and can solve the multiple problem as compared that of a part single diode. So these are the first. I'll put some. So when I can give, I can put some advantages of this variable capacitor. Okay, don't worry. So you can find also part it is used in for design voltage control oscillator. You know that this is a part one of the part device where we can control the that is called the part voltage controlled oscillator. You know, oscillator is a simple, just like a inverter in your home. Okay, so which can produce a part a sinusoidal part flow of the current. So you know that's actually it convert AC to DC, but whenever there is no current, again it convert to DC to AC for our continuous supply in our part household. Okay, so that is used in part transmitting and receiving circuit in communication system. So almost all the communication system uses the part this varicap or variable diode capacitor. Okay, and it is frequently a part also used as a frequency multiplier. Frequency multiplier in sense that we have the part different frequency part of brands, and whenever we need a part a complex frequency circuit, we can also use this variable diode capacitor. Okay, and also remote control circuit we can also part use, and it is used as frequency filter with adjustable bandwidth. Frequency filter means, so from a noise of the part of, so when the different type of noise is coming or the different type of signal is coming, when you can use this type of variable, it can allows only one particular type of frequency will pass through them for the proper operation of the part any of the instrument. That is why variable diode capacitor or varicap used in most of the modern part designing of the part instrument actually. Okay, so these are the part actually all about your part varicap. Okay, or variable part capacitor. Okay, hello, yes.
Yes, sir.
uh, So, if you have any doubt, you can, or I may be, or I can put in the part in the next class for other parts. Okay. So, I'm completing almost all the part of your syllabus actually in the electronic devices. Okay. In the next, I may be completed the part other parts. Okay.
Uh, Sir, can you suggest any good textbook other than our ignometry?
Yes. Yes. Tell me.
Can you suggest any good textbook
Yes, yes,
other
yes, yes. You can go for actually have the. Can you download the part one book actually? That is circuit for the electronic device and circuit theory. That is called your. Uh, this book is uh, yes. That is one book is actually I am following here. Electron devices and circuit theory. That is Ball State. Hello.
Sir,
Allsted.
You can it is easy for BK Metaj also, or yes, you can use this book also.
became it
And
a new version? Okay,
yes,
okay, okay, sir.
or for more, if you want more actually, as you are all MSc physics students, so one book is there, that is electron device and circuit theory, that is Ballstat. Okay, R Ballstat or Robert Ballstat book is there, so you may follow this also. Okay,
Sir, this is one book. Other book, sir.
a textbook for BK Meta you can do. Okay,
Became here.
yes, yes, yes.
So actually, in there is nothing notes in the IGNU, okay, from on this particular subject. So we are absolutely in fix how to combat the questions because there is no
Yes, yes.
material in
Don't
this.
worry. You see, I will be give the part all this part a slide to you, and also
Thank you.
the probable questions to all of you. Okay,
So nice of you. Thank you, sir.
that you can do. I can do that. No problem.
Sir,
Hello. Hello, sir. I have a problem.
Yes.
Sir, my problem is there is something problem in my phone, so I can join this group continuously. I have no WhatsApp group even also. Can you join me in the WhatsApp group?
Uh, I think that you are all in part in WhatsApp group. Actually, in the actually where I
Actually,
am
sir.
there.
Actually, sir,
So
the number I have given that is not the WhatsApp number. Another number.
so
Yes.
or
My
But
otherwise you maybe directly contact to me, because as a counselor you can take my number. Okay, but I think you were all there. I think I was in that group.
sir, I am
So
not there. So no
madam, I
problem.
suggest that madam, I suggest you just put your number. Some of the associate will add up into to any of the WhatsApp group. So that is not a problem. Just put your WhatsApp number in the dialog box. Yes, yes, ma'am.
Here, here,
Yes.
here.
Yeah.
Yes, yes. Thank you.
So you can add. You can give so that I can also add to you. Okay. So is it okay? All of you are getting my points actually. Is it acceptable to all? Means you can understand, no?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes. Yes. Someone is Smriti Rekha. Who is Smriti Rekha Vishwal? What you're telling?
Sir, give some important question in this chapter.
Yes, sure. I will be give actually. Actually, since I have the scheduled class actually there, means from the 7th, 8th, 9th. But today they have given me, but I have not prepared the course. So I'll be prepare the questions and I'll be put you. No problem. It's not issue for me. I can put many questions to you for your convenience. Okay.
Okay, sir.
Thank you, sir. Thank you.
Absolutely, I can say you are not getting any problem from my side to get actually to get any of the input from my side. Okay, so uh, okay.
Sir, can you say about the question pattern we are going to face on this examination?
Yes, sure. Let me actually this question pattern I will be shared with you. Okay. Uh, so that you don't worry about this question. I'll be just immediately after one or two or so. This is the first class, and the next class I maybe put some questions for you. Okay.
Sir, originally today quantum mechanics was scheduled or mathematical physics was scheduled. So that will be altered with the date of electronics.
I'm not getting actually what's telling.
Sir, in the original schedule, the defined subject was there, mathematical physics. Okay. Uh, the electronics was scheduled to be held from sometime in the later part of the month. Okay, or next month, early next month. Now,
Yes.
now this program is completed today. So original schedule will be transferred to that day.
No. Actually, due to some other reason, actually, what the concerned teacher actually has some issue, but he is not able to attend. That is why I put it my class, and they will be come back again. Okay.
Okay.
No,
Sir,
just
tomorrow
I
what
want to get one
time?
feedback from all of you actually. Are you just getting clear? So whatever, just I am just getting yelling down because as it is only 2 hours class and have to complete. So if you have any problem, you can put me also in the group or I will share all the detail to you all of you. Don't worry. Okay.
Okay, sir. But we do not have your number, sir. So how can we put you?
Yes.
We do not have your WhatsApp number. So how can we put you there, sir?
So my WhatsApp number is there actually. Uh, I think you may get it there actually. Okay, my WhatsApp number you can note.
Yes, sir.
Okay, 1 minute. Let me put it here.
That will be better, sir.
All of you got it?
Yes, sir. 9437
Nine.
108671.
Yes. Hello.
This one 9437 108671.
Yes.
Once you are added in that group, please share today's note in that group, sir.
What?
Once you are added in that group, please share today's PDF note in that group.
Please, I'm not getting your question. Actually, you are talking very
Sir,
slowly.
okay, so actually he meant to say that you are being added to that particular group. If you kindly share today's materials in the group so that we can get it from the group. That is
Yes,
what.
yes, yes. You see, just if
Thank
you
you.
can follow actually by this my material also, you can get everything. Okay.
Sir,
Okay,
at
sir. Okay, sir.
what
Sir, I have already
time
given my
tomorrow
number.
class will be held?
Actually, they told me because
Same time
some other
actually.
assembly is there, so I may not do. But my civil class is there actually from 7th, 8th, 9th, and 10th. Okay. So,
Okay, sir.
but if it possible, then I maybe talk to you, your coordinator, then they make it. Okay.
Sir, one request, sir, as because we do not have any materials in the electronics, please try to cover as much as possible. So we'll be benefited a lot, sir.
Today I'll share it. No
In o-
problem.
in other papers, we have something to at least follow. Whether you understand or not, that is a secondary thing. But in electronics, we do not have anything. So we have to do everything from the scratch. So whatever possible, please help us, sir.
Yes, yes,
Thank you,
yes,
sir.
yes, yes, yes. So you don't worry. I will put all this material and also for this questions related questions. I'll put it there so that it is very convenient to you for clear. Okay.
Thank you, sir.
Don't worry. Okay.
Thank you, sir.
Hello.
Hello.
Sir, already I have given my number.
Smriti Rekha, I'm not getting actually what you're
Kavita
telling.
ma'am, what's your PSC?
So there is echo. Echo is there.
Hello.
Yes.
Sir, I have already given my number. Please add you on my WhatsApp group.
Okay. Let me add. Okay. So I think
Okay,
your
sir.
number is
7608079933.
Kavita Sauna,
Rasmita Sahu.
Rasmita Sahu.
Yes.
It is
Seven six
written
zero eight.
it is written Kavita Sahu.
It is written
Kavita
Kavita
Sahu.
Sahu.
No,
Hmm.
no. This phone is. I am.
Anyway, you are using others
Yes.
phone. Okay, ठीक है.
Okay.
ठीक
Okay.
है.
Sir,
So
already. Sir, another problem is there. Ki, till now I have not found my books.
a
Anyway, that
book.
is different thing.
So actually, Kavita. So what's your name? I forget what's your name.
Yes.
Rasmita.
Yes. Yes.
Rasmita.
Rasmita Sahu is my name, but my this
Okay,
phone is
Rasmita, listen.
belongs to
So actually, this issue you can talk to the part actually IGNO office. Okay. But actually, as a counselor, I can advise and suggest. Okay. But
Sir,
as
can
the
you give
material
some
things,
number that I can contact them?
okay, I'll say let me talk to them so that they will be resolved about all the issue of yours. Okay. Today I'll talk
Okay.
to him. Okay.
Okay, sir. Sir, please add this number to the WhatsApp group, please.
Okay.
Yes,
Your
yes.
name.
All phone numbers will be added. Give the time to
Okay.
the admin. They will do it. Okay. We have
Okay.
phone numbers from different participants, as well as we have numbers of Ganesh sir to provide us the stuffs. We will
Yes.
definitely add all the numbers. Just give some
Thank,
time to the admin. Okay. Thank you.
thank you. Thank you.
Okay.
Thank you, sir.
Okay. Okay. Can we now all leave?
Yes, sir.
Kesab Sinha, who is there actually? Who is Kesab Sinha?
9031.
Sir, sir,
Actually, Kesab Sinha, your number is not added, na?
Sir, it's better you take a screenshot and then add the numbers.
Yes.
I have noted the number. I will share to different admin. Okay, you do not
Yes.
worry. I have added all. I have noted all five numbers as well as Ganesh Sir's number. We'll do that.
Okay.
Thank you.
Okay. Thank
sir,
you.
sir, sir. Hello.
Sir
Yes.
already added groups, so please send today note.
Sir, sir, please,
Yes, please tell.
sir, please
Sir,
repeat the referral books that is there.
Okay, if there is no issue, then I'll let me
Sir,
or
please
any or any
repeat
problem
the
or anything
person
that you
name.
want to ask.
Sir, please repeat the referral book author name.
What?
Referral book author name that you have told.
I told already the part. You can see also. Let me write actually here.
You suggest the book, electronics book. Please repeat the
Electronic
author name.
devices and circuit theory. Robot.
One is BK Mehta, and other is there. You can just let me write.
Electronic devices and circuit theory. This one.
Yes, yes.
Robot. Something. Some
Also,
name.
so it is also available. Also, you see PDF, and if you can, then I can also give that PDF to all of you. Okay.
So if you have, then you can please share that in the group.
That book is with me. Okay.
Okay, sir.
So if you want, then I can also put it actually in a WhatsApp group. Okay.
Yes, sir.
Yes,
Yes,
Sure,
Sure,
sir.
sir. Sure, sir. Thank you.
Okay. Okay. Fine. Thank you. Let me put leave.
Thank you, sir.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.